a session about an hour ago that was the same page.
Okay.
In fact, might be a little easier to read without all of the marking on it. I don't know. What would you prefer?
Well, I just did those problems, so I just have to do the
Oh,
other.
so you just need to do the bottom four.
Yeah.
Okay. What's the green writing? Is that yours or your teacher's?
That's my teacher's.
Okay. Not real sure what she wrote there. She says volume is x over 360 times.
Yeah, because it's the hemisphere, but it's also the sector of the hemisphere.
Well, I don't think she's right. Shall we start with 5? Or
Let's just do 6.
shall we start with 5 or 6?
Yeah.
6?
Because if he's grading it, then I might as well just do it his way.
Okay. I think he's missing a big piece of this over here, which is what percentage of the hemisphere do we have? Well,
Oh, yeah, you could do 288.
right. It's 288 divided by 360 is the percentage.
Mm-hmm.
In other words, we don't have a full hemisphere here. So,
Yeah, he was just giving the equation. Or, like, the formula.
okay. All right. Let's go to 6. First of all, how are you on all of these general equations? Do you have them all memorized?
Yeah, I get them confused sometimes, though.
Okay. That's the key to all of these. The absolute key is you start with the general equation and then you fill in everything you have and solve for any unknowns that you don't have. Okay? If you're having trouble memorizing some of these general formulas, let me suggest a foolproof method. Make yourself flashcards. On one side of the flashcard, say volume of a sphere. On the other side, say 4/3 pi r cubed. And then make another flashcard for the volume of a cone, and so forth and so on. Okay? And then give those cards to your mother and have her test you. Just by drilling, that is a great way to memorize stuff. A terrible way to memorize stuff is to always have the formulas in front of you, like right now. If you had your book open or if you had a page that had all the formulas on them, I would say turn it over so you're not looking at it. Because it's really important that you test yourself on whether you really have these things memorized. If you don't, there's no way you can succeed on these tests. You absolutely have to start from the general formula. Number 6 is a regular pyramid. It's difficult from the drawing to figure out how many sides it has, correct? Do you agree?
Mm-hmm.
Yeah.
Yes.
But the reason they drew it like that is for a reason. You don't need to know how many sides it is. First of all, we'll start with the general formula. What is it?
ASN divided by 2 times the height divided by 3.
Well, hold on. Yeah, let's start with this. Okay, that's always the general formula if it goes to a point. Whether it's a cone or whether it's a hexagon or a triangular pyramid or anything, you start with this. Okay, now in our case, B is, what did you say it was again?
ASN over 2 divided by 2.
Correct, but there's another one. In other words, on your flashcard, you should have the area of a regular polygon, and your answer should be 1/2 ASN on the back, but also 1/2 A times the perimeter. And you can see why the perimeter works, because the perimeter is S times N, right? The side length times the number of sides. But this is a more useful one to use for this problem, because they ask for the perimeter, and we don't know what S is, and we don't know what N is. So now, I guess we know S, don't we? What do we know? We know A.
No, A.
A. And so the only unknown we're going to have is the perimeter.
And we know S because it's going to be the same because it's
Well,
a 60-60-60 triangle.
Well, only assuming it's a hexagon, and I'm not sure it is. So we're not really going to be able to figure out what S or N is on number 6, but we will be able to solve for the perimeter. In other words, at this point, our volume is now equal, instead of the first general equation, we're going to use this one. So that's the area of the base times the height. So fill in everything that you can, that you know, and now we know the volume is 52057.6 equals 1/3 of 1/2. A is that measurement right there. What is that, 33.2?
Yeah.
P is the unknown, and we know the vertical height. It's 42, right?
Uh-huh.
So once you end up with an equation and only one variable, now you're home free. Now it just becomes an algebra problem, not a geometry problem anymore. And I don't think we should spend our tutoring time doing the arithmetic here.
Mm-hmm.
We should be working on other stuff if you don't know how to solve for P. You know what I'm saying?
Uh-huh.
I'm going to assume, and if I'm wrong, please let me know, because if you need to go through the rest of the math here to solve for P, we should do it. But I'm going to assume you can solve for P. Okay, and that's what they want. Now, if I didn't have P and I had Sn there, which would be my other alternative, now notice that I have two variables. I can't really solve for S or N unless I know one of them. And they don't draw this figure in a manner which allows me to figure out it actually looks almost like a 7-sided. I see 2 there, there's 3 up front, and there's 2 side ones. So it might be a septagon, but it doesn't matter. We don't have to know whether that's 7-sided or what. And then we'd have to solve for S, and then we'd have to go back and resolve for P. So P is the much better formula to use when they're asking for P. Okay?
If I were to break it into like triangles,
you don't know what the base is? Can you tell if the base is 6 sides or 7 sides? I can't.
I think it's 7. But like if you could on a different problem on a 6.
Yeah, if you could figure that out, well then you know it's got 6 sides and you can use the ASN. But it's still going to be it's going to be one step longer, because you're going to figure out S, and then you're going to have to multiply that S by N to get P. So you're going to have one more step to do. Whereas if you use this formula, you immediately solve for P. You also don't care whether that's 6-sided or 7 sides. And we don't know the side length. We don't have a side length anywhere. So, of course, we'd solve for the side length. But anyway, let's go on. Number 7. What kind of figure is number 7?
Uh,
Says right below, it's a trapezoidal pyramid. Excuse me, a trapezoidal prism. Let me blow this up just a little bit bigger so that I can handle it a little better. Yeah, there we go. Now, a prism is defined by having 2 equal, opposite, and parallel bases, correct?
yeah.
They have to be equal, they have to be opposite, and they have to be parallel. What are the bases in this prism?
The trapezoids.
Well, okay, so it's not that rectangle, it's not this rectangle, it's this face right here. Because it has a opposite face over there, and they are parallel. Okay? They have to be. For this thing to be a trapezoidal prism, you have to have parallel bases.
Mm-hmm.
So this is what we need to solve the area. So let's start with the general for a prism. What's the general for a prism?
Base times height.
Capital base. Only to distinguish it from base times height of a rectangle. In other words, if I have a rectangle, there's base and there's height, and the area is base times height, but this base is a linear measurement. It's measured in feet or inches. This base up here is not a linear measurement. That's an area measurement. And that's why it's a capital B instead of a small b. The capital B is to distinguish it from this base here. They're not, this is measured in square feet or square inches. Okay? So that's the general for a prism. So now let's get the specific for this prism. That's the second step always. What's the area of the base of that trapezoid?
22 plus B2 times 10 divided
Let's
by
give
2.
the general. Everybody wants to step into the numbers. Let's do the general. I can't stress how important it is to always do all of these problems by starting with the general. Okay? So what's the area of a trapezoid, the general?
Base 1 base 1 plus base 2 times h divided by 2.
Okay. And notice this h is not the same as this h. The top h is the distance between the two trapezoids. That's 29. And yet we're going to call it h just because that's, but it's very important that we distinguish it from this h. Maybe we should call this h sub 1 and this h sub 2. Okay, so they're not the same thing. So now we have the volume equals base 1 plus base 2 divided by 2 times the height of that trapezoid, I'll make it a t, times the height of the prism. Make that a p. Now we have the general with all the variables. Now we need to fill in everything. Well, tell me what I can fill in. What's V?
5220.
What's B1?
22.
What's B2?
B2.
Or X. Since they're asking us to solve for X, we're going to call that X. That's B2. What's H of the trapezoid?
10.
And H of the prism?
29.
There you go. You always end up coming down to one equation and one variable. And again, I'm going to assume you can solve for x easily there. Okay? All right, number 8. They're asking for a lateral distance. That's okay. Let's start with the general. We'll see if we can figure it out. I'll always start with that general. Specifically to this, oops, excuse me, I left the 1/3 out. Apologize. It's not a prism. If it goes to a point, it's always 1/3 of capital B times H. What is capital B?
Pi r squared.
And H, I'll just leave it as that for the moment. Okay, now let's fill in everything we know. Volume?
20,328.
Notice that most of these volumes have a pi, and the pi is almost obscured, especially if it's cubic millimeters like the first problem was. So it's really easy to miss that pi, but it's there. Okay. And it's going to cancel with this pi over here, so it's going to be very helpful to have that answer in pi. What's the H?
56.
Okay. We now have one equation and only one variable. We can solve this for R. That's not X, though. Without spending time doing all the arithmetic, let's guess at what R is. Let's say R is 20. Okay? Now let's figure out how we're going to get X. If we look at a side view of this cone.
R is 33.
Okay, cool. That's better. Use the real numbers. Now if we look at a side view of this cone, looks kind of like this, right?
Mm-hmm.
Well, if I draw that vertical there, and I know that the radius is 33, which is that measurement from there to there, and this side is 56, that's how I solve for X. So what is X equal to? I mean, what's the, not the number, but how do I get X?
33 squared plus 56 squared equals X squared.
Okay, which means X is the square root of 56 squared plus 33 squared. And that will give you your answer on that one. Number 9. What's that doing at number 9?
You're finding the height.
No, I know, but they're supposed to get harder. And that's the easiest one on the page, is it not? What's the general?
Base times height.
What's the specific for this rectangular brick? You can say width times length times height. Okay? Just because we don't have any other dimensions on here. Well, they give us the volume, so that's 9367. No pi. Width, 19. Length, 29. X is the piece of cake to solve for. Okay? All right, let's finish up on 10, which looks like it could be a little trickier. Okay. What are we going to start with?
V equals x over 360.
Equals what?
X over 360 times base times height.
Well, that's why I said let's start with the general for a right cylinder. And then we'll massage it as we realize what we're looking at here. But the general is base times height, and the specific for a right cylinder is pi r squared times height. Okay? Now, the specific for this particular solid is an adjustment of that. It's pi r squared times height times what? You said it. X over 360.
Oh.
Ah, not x over 360. That would give us the volume of that little sliver. (360 minus x). In other words, if the volume of this entire piece of cheese here would be this angle, well, that angle is 360 minus x, is it not?
Yeah.
Okay. So if I want the volume of this relative to the volume of the cylinder, it's got to be 360 minus x. If I use x over 360, I'm getting the volume of this little cut out piece of cheese there, the missing part. Okay, and I'm still trying to solve for x. That's that angle, but that's the volume of my object that I'm looking at is the volume of a right cylinder times a fairly high percentage of it. You're going to get that by doing 360 minus x over 360. Okay, and now they've given us everything. They've given us the volume, they've given us the radius, and they've given us the height. So the next thing is going to be 5250 pi, notice that pi there, equals pi times 15 squared times 28 times this. Now, that looks like it might be tough algebra, but it's not. First of all, these pi's always cancel. And
should I ever just do x over 360 and then subtract it from 360 after?
Well, the problem with that, no, oh yeah, I guess you could, but then you shouldn't use x. If I were to do x, okay, I would be actually solving that angle there, the big angle. And then, yes, I could subtract that number from 360 to get what they're calling x, but you really wouldn't want to call it x, you should call it y.
Okay.
Something different than x. Well, the thing to really call it, if it's different from, let's make it 360 minus x, because that's what it is. It doesn't make the algebra that hard at all. The algebra still is a piece of cake. You're still going to get rid of this denominator by multiplying both sides. You're going to divide both sides by that. You're going to have 360 minus x equals some number. It's going to be easy to solve for x. But yes, always make sure. I noticed there were a couple of problems here that were kind of like that, where you could easily make a mistake by making that x over 360. That's not going to give you the right answer. But you would see it, actually. Let's say you did make that mistake, and you made it x over 360. Well, you're going to come up with an answer that's clearly greater than like 30 degrees, right? And you're solving for this big angle, so you're going to come up with an answer that's like 315 degrees. And then you're going to look at it and you're going to say, well, that doesn't make any sense. That's not a 315 degree angle. Well, so then you'd subtract from 360 to get your answer. But that's kind of a odd way to do the problem and not really a proper way to do the problem. This is the proper way to do the problem. Just like that. But notice I cannot stress this more. If I stood on my head, every one of these 10 problems we did by starting from the top. Sometimes that's capital B times H, sometimes it's 1/3 capital B times H. Then we go to the specific for our shape, and then we start filling in stuff. Finally, we get it down to one variable, the one they're looking for, and we can solve for it. Same exact steps. So that's why it is so important to have the general formulas memorized for all of these. I think you do. You seem to know most of them. The only one that you didn't know was that formula for the base of that regular, whatever it is, the regular polygon. Knowing that it was also 1/2 the apothem times the perimeter was necessary for this problem. It would have been an extremely difficult problem even if we worked out that that had 7 sides to it. All right. Quade, I got a feeling your mom told me what your grade on the last test was, and I got a feeling what might be happening is you're waiting too late to come see me. And that maybe a better plan of attack would be if you just schedule a half hour every week, and we'll have a much better chance of keeping you current. It's really hard to work after the fact, as I'm sure you can appreciate. If we were to go back over and cover that test that you got a 55 on, that's not gonna. Then we're wasting away from time like on this material that we could be doing. So it's a tough thing. Once you get behind, it's very tough to get caught up. And the way to avoid getting behind is to just do it regularly. Don't wait until you have a quiz coming up to schedule a session. That's what most people do, and to be quite honest, that's a horrible way to get tutoring. It just is. It's cramming before the test. It doesn't work. It's not really effective. Now, maybe a half hour a week isn't enough even. You might even want to consider doing 2 half hours a week, depending on how far behind you feel. Your mom said you were getting kind of frustrated. I guarantee I can help you, but you got to give me the time to do it. Okay?
Well,
all right. I will.
I think we were planning on that anyway.
Okay, good. If you find like there's a certain time of the day and day of the week that you want to do regularly, just text me and I'll lock it up so that you don't have to constantly go in and schedule it. In other words, tell me one time and I'll lock it up for the rest of the semester so that nobody else can go in there and grab that spot. Okay? All right. Have a good weekend. I'll talk to you next time.
Thanks, you too.
Bye-bye.